The research began several years ago. In 2006 was the first grant. It was funded by the National Science Foundation, and we were using fire to make new materials. It's called combustion synthesis. So this began as really, can we engineer new materials for specific applications? At the time, we were working with the Defense Threat Reduction Agency, and they were looking for solid and gaseous materials to combat weapons of mass destruction. And so we were really creating them to be resistant to materials like anthrax. We worked with the DoD for quite a while, and then we began to commercialize the material. So we were then developing it more for commercialization, construction material types of use rather than just looking at defense applications.
So the final product is a powder. It's a combination of different metals and metal oxides. And one of the coolest parts of the product is that the constituent ingredients are actually approved for use within the human body. And so what we're doing is taking materials that are already existing, already in use in a bunch of different applications and markets, and we're optimizing them.
With obviously the detriment from the hurricane that came through, we were able to start optimizing this towards killing molds and mildew and fungi and things like that that'll grow on the walls and on the studs in the houses. And so we've really been working to make this powder something that's really available to household use. So you can just go to your home improvement store, mix it into your paints, and apply that right onto your walls and protect against all these harmful microorganisms.
Again, those materials have specific properties, and when we mix them together and use fire to create this new material, what happens is the material produces a shield basically on the outside of it. So if you have a gallon of paint, you mix in our product as an additive and paint it on your walls, our product will serve as a shield against mold growth, against mildew, and really mold spreading in general. But what we also see is that over time, where microorganisms would continue to grow at a very high level, we see that our material provides a lasting, continuous effect, so that bacteria growth curve doesn't happen.
So one of our big applications right now is NavAir, which is the Navy Air Force. They're really wanting to coat all sorts of different parts on the airplanes, and one of the big problems they have is when they send these airplanes over to hostile environments, going into places with really harmful bacteria, is they have a problem with the bacteria getting inside of all the crevices inside the airplane, which ultimately causes damage to the airplane and is a health risk coming back here to the United States.
Our first customer and our first sale was to a company out of Colorado Springs called RMB, and what they do is they apply a very thick plastic lining to offshore oil rigs. So one of Shell's offshore oil rigs has this pipeline that goes really deep into the ocean. Water from the rig is pumped out of that pipeline. But when no water is being pumped out, it is susceptible to any sort of clam growth, any sort of biofilm happening on the inside of that pipe. And so in a stretch of their pipeline, they just added our additive into their plastic to prevent that biofilm from happening.
The material has been patented by the Texas A&M University System and West Texas A&M University. We're really excited about that, because then we have the rights to use the material and develop the material as we need to. We have a product right now that is user-friendly, ready to go, and the next step is just getting it into the market.
So we're hoping to be available commercially online within the next quarter, and within the next year we hope to be on shelves throughout the U.S.